Just a few more minutes as joining us today. And good afternoon. Welcome to today's local government education program provided by the University of Illinois Extension. My name is Lisa Merrifield, and I'm a Community and Economic Development Specialist at the University of Illinois Extension. For sound quality, we've muted microphones during the presentation. If you have any problems connecting, add those questions to the chat space and we'll monitor it. If you have questions for our presenters, also add those to the chat space. I'll be monitoring those and will pose those questions to our speakers at the end of our presentation. A recording of the webinar will be made available on our local government education website and our YouTube channel. Participants will receive slides, links to related resources, and the recording for today's webinar. Today, we're talking about preparing for extreme weather this spring. Our speakers are Trent Ford and Sally McConkey. Trent Ford is Illinois state climatologist and provides weather and climate data, maps, and information for Illinois farmers, government agencies, and policymakers, and all citizens. Trent also conducts research on past climate events, monitors current conditions, and studies possible future climate change, and acts as the state's spokesperson on climate science. Sally McConkey is a registered professional engineer and a certified floodplain manager. She manages the Coordinated Hazard Assessment and Mapping Program and partners with the Federal Emergency Management Agency. Sally performs hydrologic and hydraulic flood studies, digital flood insurance rate map production, and does community outreach. At this point, Trent, I will turn it over to you.
All right. Nancy, can you hear me okay?
I can hear you, Trent.
Great. Okay. So yeah, thank you all for taking your time out of your day to come here to talk about, for me, focusing on extreme weather as it relates to climate change. And so, as Nancy mentioned, my name is Trent Ford. I'm the Illinois State Climatologist there at the State Water Survey at the University of Illinois. Today, my part of this presentation, I'm going to be talking about climate change as it relates to extreme weather events in Illinois and impacts that we've seen. The majority of what I'm going to talk about is historical climate change, that which we've measured over the last 100 to 150 years, although I will throw in some information about future projections as well. Okay, so I cannot give a presentation about climate change without going into some of the fundamental science behind it. So this schematic here that you're seeing is just a simple schematic of Earth's energy budget. So we get almost all of the energy that we use here at the surface from the sun in the form of a shortwave radiation. Now that shortwave radiation interacts with the atmosphere, it gets transmitted through and absorbed by the Earth's surface, where it's used to do many different processes. The Earth's surface then emits a fraction of that initial energy as a different type of radiation, long-wave radiation. Now, certain gases in our atmosphere that allow the shortwave radiation from the sun to come in to the surface can block, trap, absorb, whatever verb you want to use there, the long-wave radiation coming from the surface. And therefore, the concentration of these gases, known as greenhouse gases, influence the large-scale energy balance of Earth. Now, there's many different types of greenhouse gases, but the three that are most commonly associated with global warming or long-term climate change are carbon dioxide, CO2, methane, CH4, and the gas form of water. Now, these three gases, especially carbon dioxide, which has been really the main driver of climate variability for Earth's history, they vary on long-term and short-term timescales due to both natural and anthropogenic causes. And so it's really the long-term and as well short-term variability of carbon dioxide that drives what we're going to talk about today, which is global warming and its impact to climate. What we have observed over the last 100 years or so is a precipitous increase in carbon dioxide concentrations in the atmosphere. To give you an idea, the January 2020 measurement on Mauna Loa in Hawaii was 413 parts per million. That's our volumetric measurement. Going back to, you can see the graph here, going back to the late 1950s, we were at about 320 parts per million. Now, using paleoclimate records from ice cores, we can extend observations of carbon dioxide all the way back to about 800,000 years. And over that 800,000 year record, the amount of carbon dioxide in the atmosphere never reached over 320 parts per million. So we are today at a higher level of carbon dioxide than we've been over the last 800 to 900,000 years. And so because of that increase in carbon dioxide concentrations, we're keeping more of that initial energy here on Earth, which changes the overall energy budget and increases temperature. And that's what I'm showing here. So this is showing in global average temperatures, or the change in global average temperatures expressed as an anomaly going all the way back to the late 1800s. This is from the NASA GIST record. What I'm showing you here is global warming. It's the increase in global average temperatures that's been observed since we took consistent observations since about the mid to late 19th century. Now, this is the change in global average temperatures. However, because the Earth's climate system is so complex, it gives me some job security. What that means is that an increase in the global average temperature doesn't necessarily result in the same type of change in climates everywhere. And so that increase in energy here on Earth that increases our temperature also changes wind patterns, changes large-scale atmospheric circulation, changes ocean-atmosphere interactions, and makes for different changes in different climates around the Earth. So global warming causes climate change. They're not synonymous. And so what we're going to talk about today is really what we care about as far as impacts are concerned, and that is the climate change. I'm going to focus today mostly on precipitation. Of course, I think most folks are interested in those types of extreme weather events. And because our timetable doesn't really allow me to go much into precipitation and temperature, I really want to focus on precipitation. However, as I'll mention towards the end of the talk, if you do have questions about any sort of extreme weather events or climate changes and impacts thereof that I haven't discussed in this talk, please, I'll give my contact information. Please feel free to reach out to me. So what I'm showing you here on the right-hand side is annual precipitation statewide in inches, going all the way back to 1895. So it's a statewide total precipitation each year. And you can see an increase at that time, about 0.43 inches per decade, increasing annual temperature between 1895 and 2019. So about a half inch per decade. So we're getting about 5 inches wetter than we were at the turn of the last century. If we calculate that trend since 1990, over the last 30 years, we see an increase of 1.33 inches per decade. So almost 3 times the magnitude increase in total annual precipitation over the last 30 years than we've seen over the last 100 years. So overall, Illinois is getting wetter. That's really not a surprise to anybody. However, those wetting trends are increasing in magnitude, especially over the last 30 years. When we break it down seasonally, spring and summer wetting trends are much larger than winter and fall, even expressed as a percent of the total amount of rainfall that we get in those seasons. The largest trends are still in spring and summer. And spring actually expresses a percent of how much rainfall usually happens in spring. That's actually the largest trend. So springs have been getting wetter than any other season. To give you an idea, just some statistics here to kind of bring this home to specific points. 5 of the top 10 wettest springs on record, going back to 1895 in Rock Island, Aurora, and Mundelein, have occurred since 2009. So about half of the last 10 years worth of springs are also in the top 10 on the entire record. So we've really seen in the last 10 to 20 years this pretty much unprecedented wetness, especially in the springtime throughout the state, but the magnitudes are actually a little bit larger in northern Illinois. Not to be outdone, in Belleville, they've experienced only 10 drier than average springs since 1989. So over the last 31 years, Belleville and most of the state has experienced about twice as many wetter than average springs than drier than average springs. So again, the state is getting wetter overall. All seasons have gotten wetter, especially since the beginning of the 20th century. But those trends are largest in the springtime. We also see increases in not just total precipitation, but the contribution from extreme precipitation events. Now, those can be defined in many different ways. Here, using plots from the long-term co-op observation station in Streeter, this is just showing the change in extreme precipitation events, those which drop 2 inches or more precipitation in a 24-hour period. So the bar plot on the right-hand side, green bars are showing 5-year periods where the annual number of extreme precipitation events was well above normal, and the gray bars are below normal. So you can see over the last 15 to 20 years, we've had many more years when we've had above average occurrence of these extreme precipitation events. And we can talk about the hydrologic impact of those extreme precipitation. I'll discuss that in a little bit. But what this means is that we're not only getting wetter, but annually, a larger percentage of our total annual precipitation is coming from these extreme precipitation events. So if in some places, if we're getting 40 inches of rain annually instead of 36 inches of rain, it doesn't necessarily mean that we're getting 8 half-inch rain events more or 12 third-inch rain events. It's coming in larger totals, more extreme precipitation events, which of course has some pretty significant hydrology impacts. So one thing I like to talk about is, since we're talking about climate change here, I like to disentangle variability and change. Really what we've seen, especially over the last 30 years in Illinois, is a period of unprecedented wetness as far as observations are concerned. However, if we go back, extending records using long-term observations from a few stations that have been taking weather observations since the mid-1800s, we can see what I'm showing you here on the top right-hand side, which is a figure that was created by Vern Knapp in a 2005 paper, that the 1840s and 1850s were similarly wet to what we experience today. And you can see that over that record, since beginning of the 1840s, we have a decent amount of long-term variability. And actually, if you break down Illinois' precipitation, there's about a 20 to 30-year periodicity where we go through wetter than normal and drier than normal conditions. At the same time, we are experiencing an effect of our annual and our total precipitation from climate change. A lot of that is due to what I'm showing you on the bottom left, which is just an expression of the Clausius-Clapeyron equation, basically saying that as the temperature of the air increases, the saturation vapor pressure increases, meaning that more evaporation can occur and that that air has a higher amount of potential for humidity. And the higher the amount of humidity means that our systems that come through that generate our precipitation can create more overall precipitation than they were when temperatures were lower. So the change in precipitation, both in total precipitation as well as the change in extremes, has a climate change signal to it. The last 30 years of what we've seen as far as precipitation changes and the total amount of precipitation that we're getting is a function of both long-term climate change as well as climate variability. So to kind of put this in perspective and maybe take a few more focused look at local impacts, I want to take a number of events that have occurred over the last year and put them in perspective as far as a probability of these types of events occurring, kind of like a precipitation recurrence interval. And this really falls on the heels of the new publication of estimated precipitation recurrence intervals in the new Bulletin 75. It's the update of the original Bulletin 70. This was completed by Drs. Jim Angel and Momchila Marcus last year. And what this allows us to do is to look at the change in precipitation recurrence between the original Bulletin 70, published in 1989, and this Bulletin 75, published 30 years later. So the first event was from September 27th of last year, quite an incredible event where we had 9 inches of precipitation that was observed in a 24-hour period in Minonk, which is in Woodford County in central Illinois. Now, I say less than 24-hour period here just because at the co-op site at Minonk, the observer takes 1 observation every 24 hours. However, looking at the radar returns, it is likely that 9 inches fell in a less than 6-hour period, which is absolutely incredible. Now, based on the probability of this event estimated in Bulletin 70, as far as a 24-hour recurrence or a time interval, the probability of this type of event, that 9 inches in a 24-hour period, has increased 4 times since the Bulletin 70 publication in 1989, based on the new estimates in Bulletin 75. So a lot of the impacts I'm showing you on the right, the photos from the bottom photo from an area near downtown Peoria, the top photo from a small town in central Illinois, you know, the probability of this type of event occurring is increased by about 4 times. So that really, I guess, gives a good example of how the impacts of we're seeing of this change in precipitation across the state. Another example, on September 3rd of last year, we had about 2.5 inches of rainfall in a 90-minute period in Morris, there in Grundy County, Morris High School flooded. There's a lot of flooding in fields and trouble for farmers who had already been in trouble because of planting delays last year. The probability of this type of event has increased 4 times since the Bulletin 70 publication as well. In Bulletin 70, this event was a 20-year event, so the 5% chance of occurring any given year, and now it is a 5-year event in the re-estimated Bulletin 75. Not to be outdone, we have had our extreme precipitation events for this year as well. Between January 10th and January 12th, we had about 5.6 inches in a 3-day period in Charleston, there in Coles County. Now, this was incredible no matter what time of the year it was, but the fact that it happened in January was even that much more incredible, because we tend to see our extreme precipitation events when there's more water vapor in the air, meaning anytime in the warm season typically. So it's very rare that we'll get anything over maybe 1 or 2 inches in a 24-hour period in January, and getting 5.5 inches in that 3-day period was really incredible. Caused a lot of flooded fields. Of course, there's not a whole lot of soil water holding capacity in the wintertime. Kaskaskia River breached the Vandalia levee because of this event. And again, the probability of this type of event has increased 4 times also since the Bulletin 70 publication in 1989. So again, these impacts that we're seeing, the likelihood, the probability of these occurring because of the change in extreme precipitation has increased along with our increased precipitation. So really the focus here on precipitation intensity is important, especially because Sally is going to be talking about flooding. The more intense precipitation, of course, increases our runoff ratio. And so as we get more intense precipitation, the soil can only hold so much at so much time, and so we get an increased partitioning to runoff. In agricultural fields, this can lead to things like nutrient runoff, which decreases environmental quality, water quality. In urbanized areas, that can lead to flash flooding, which of course is problematic for lots and lots of people. The map, or the table I'm showing here at the bottom, is from a study done here from the Water Survey led by Walt Kelly in 2018 that estimated the amount of precipitation, stream flow, and then estimated the amount of evapotranspiration within the Vermilion watershed over 2 time periods historically. The first between 1932 and 1964. The second was between 1970 and 2016. So if you look at the 2 bottom rows there of this table, we see that precipitation over the Vermilion watershed has increased by about 3.5 inches between these 2 historical time periods. And stream flow has increased even more. And so what that means is a larger yield of precipitation to stream flow as opposed to surface storage and evapotranspiration. And that can be directly connected to increased precipitation intensity. So even if we are getting wetter necessarily with total more annual precipitation, it doesn't necessarily mean that our soils are always getting wetter and that we're yielding more evapotranspiration. So what this means is, and I could talk about this a little bit more when I talk about drought, that even though we're getting wetter, we're not necessarily decreasing the probability or likelihood of short-term drought, because we're not converting precipitation into surface water storage as effectively because of that increased precipitation intensity. Okay, so all of that is historical observations, and we can talk a little bit about what has been projected, or what climate projections are showing for the future. What I'm showing you here is from the U.S. Climate Resilience Toolkit, which is a very useful set of tools for understanding and analyzing future climate changes and projections of them. This is just showing from Carroll County here. What this is showing is total annual precipitation is projected to increase, as is the frequency of extreme precipitation events. The blue line and the red line here on the right side of the plot, those are showing 2 different series or scenarios based off of changes in carbon dioxide concentrations. What that's showing is that, first and foremost, the uncertainty in precipitation projections, which is all of this shaded area on the right-hand side, the uncertainty far outweighs any sort of long-term signal. It also, because of that, means that future changes or increases or decreases in the amount of carbon dioxide they emit to the atmosphere does not necessarily affect the precipitation changes, the outcome of precipitation. So even though it's kind of a paradox, even though the signal for climate change is actually strongest for precipitation in Illinois relative to temperature, the uncertainty for precipitation projections are actually higher, much higher than they are for temperature. And the reason being is that the global climate models have a much more difficult time capturing especially extreme precipitation events, which can happen over a very small area that may not be able to be resolved. One thing that I will point out, though, of this and on my next slide is that projections do show consistent wetting in springs and drying in summers. That's what this plot here shows. So this is just taken from LaSalle County, showing monthly total precipitation in inches. The kind of beige bars here show the historical observations. So just like we would expect anywhere in Illinois, our wettest time period is between April and July, driest time between December and March. The blue bars here are showing the projected total amount of precipitation by 2050 under the quote unquote low emission scenario. And the other color, brownish, you can't really describe it very well there, is the same 2050 projected changes in precipitation under high emissions. The thing I want you to see here is that for March, April, and May, we see that the projected future changes in precipitation by 2050 are much higher than the historical observations, but the signal's actually reversed for July, August, and in some cases, September. So what this is suggesting is that springs will continue to get wetter, but summers will begin to dry. And this is something that global climate models have suggested for quite a while, that we may get into this period of very, very wet springs and very dry summers. Now, in talking to farmers, this really worries a lot of those folks because we're talking about flooding in spring and drought in summer, which is about the worst thing you can have for large-scale crop agriculture. However, I will say that if we go back to the historical observations, summers in Illinois have gotten wetter, especially over the last 30 years. And so even though it is very likely, based on projections, that spring will continue to get wetter, whether or not summer gets drier is something that is still undecided, is still being explored as far as research in climate change science. So let me talk a little bit about snowfall. So winter warming, as far as absolute temperature change, winter has seen the largest changes across Illinois. So winter warming has caused a decrease in seasonal snowfall across much of the southern Midwest. That does include southern Illinois. When we look at long-term trends, though, snowfall changes in this region are much more complicated than overall precipitation. It's dominated by variability. So what I'm showing here on the bottom left is seasonal total snowfall in 5-year increments from the Peoria airport, going all the way back to the mid 1940s. The green bars are above average snowfall. The gray bars are below average snowfall. So you can see really over the last 10 to 15 years, we've actually had more snowfall in Peoria than the long-term average. The biggest thing, though, here is that the 1970s are really dominate the snowfall signal because we had that handful of very intense winters. What that means is that trying to pull out statistics from snowfall records can be very complicated. This is made even more complicated from what I'm showing on the right-hand side, which is a plot from Bob Davis's paper in 1999 showing how snow water equivalent, the amount of water that can be yielded from snowpack, how that varies as a function of temperature. And what this is showing is it's not as simple as when you warm, you get less snowfall. That may be the case, but the amount of snow water, amount of liquid water equivalent in the snow actually peaks when temperatures are 2 to 3 degrees below freezing. Once you get close to freezing and warmer than that, of course, then you begin to really net much less snow water equivalent from that snow. What this means is, especially for central and northern Illinois, as we've seen winters warm, it actually can contribute to more or increased snowfall and increased snow water equivalent because you have more humidity in the air that can add to that snowpack. It is likely, though, that as we continue to see warming into the future, we will see significant decreasing trends in winter snowfall and winter snowfall snow water equivalent moving into the mid part of this century. All right, so Drought is something that is actually that's a major part of my professional research is in drought. Drought is complex, and its complexity complicates its measure and its projection. On the bottom here, I'm showing two plots. The first one is an annual time series of Palmer Drought Severity Index, and the right is showing that same time series just with a 30-year smoothing window. If we use the Palmer Drought Severity Index, which is just one index, extreme drought, which is a PDSI of -4 or below, has been reached only 7 times since 1895 in Illinois. So we haven't had a whole lot of very long multi-year droughts in Illinois. However, that extreme drought has only been reached twice since 1965. And when you apply that 30-year smoothing window, as I do on the right-hand side here, what this shows is that in the blue, we've really, since the turn of the 1970s, have really experienced an unprecedented wet period of time where we have had a pronounced lack of multi-year or water supply droughts. We just have not had those multi-year droughts that have affected in a significant way water supply all across the state. Thinking back to droughts like the 1930s and parts of the late 1950s, early 1960s. The last few droughts we have had, we had a drought this last year in 2019 in some parts of the state, going back to 2012, 2005, 1988. Those were droughts that got very severe, but only lasted one growing season, therefore had major agricultural impacts, but water supply impacts were relatively isolated. One thing we are seeing as far as changes in drought is not so much the frequency, but the characteristic of drought. And so thinking about this last year, if we think, what is 2019 like? It was the 5th wettest year on record statewide in Illinois, but we had drought and we had agricultural impacts related to that drought. And so to give you an idea, on the left-hand side is showing monthly precipitation as a departure from normal in Monmouth, in Western Illinois. Monmouth experienced its wettest May on record last year, followed by its 4th driest July on record, followed by its 9th wettest September. So it was a swing in extremes that caused some significant impacts related to agriculture and people's psyche, as well as mental health impacts. Another good example here, showing 3 maps or 3 weeks from the U.S. Drought Monitor, where in September 10th, we had some drought across the I-74 corridor in central Illinois. And then a few weeks later, on October 3rd, no drought here in central Illinois, but we see drought up here in southern Illinois, and actually got down to severe drought, which is supposed to be a 20-year event in Hardin and Gallatin counties. And then 4 weeks later, in November 5th, there's no drought. So we really had this swing from wet to dry, and some, I guess I can call it cutting edge research, although it feels like I'm tooting my own horn a little bit more than I should do there. But research that I've been doing here at the State Water Survey is suggesting that these swings from very wet to short-term but extreme dry conditions back to wet are actually increasing in frequency across southern Illinois. There's a lot of work that needs to be done with this. But what this is suggesting is that even though we're not seeing those long, multi-year pronounced droughts that we did earlier in the 20th century, we're still seeing impacts related to short-term but intense dry periods across the state that come on very quickly from longer-term, very wet or pluvial periods. So as far as precipitation, the impacts on soil and water availability, just to start summarizing this here, we've seen in Illinois more precipitation and more extreme precipitation. Of course, it increases runoff, it increases soil erosion, and it increases the risk of flash flooding in urbanized areas. All seasons are getting wetter. I should say at least over the 100-year time period. Fall is actually the only season that's gotten slightly drier over the last 30 years. But also the last 100 years, we've seen all seasons get wetter. The largest trends have been in spring. We've seen, if I start my trend line when I'm estimating my statistics in any year between 1895 and 1990 for a 30-year trend, every single 30-year period, spring has gotten wetter. And the projections from climate models are showing that suggesting that should continue. The recurrence intervals of heavy precipitation events are shortening. Of course, it means more runoff, it means more flooding related impacts as well. And projections indicate that these trends should continue in future decades, especially in winter and spring. Where we see the alignment of precipitation projections with the historical observations as we do in spring, that's when we have some confidence to say, okay, the mechanisms that are driving this are captured well by the models, and therefore we can have high confidence in what they're showing. Winter precipitation will change as temperatures continue to warm. We've had a bit of delay in that, especially in central and northern Illinois, as I mentioned, with the relationship between temperature and snowfall. More winter rainfall will increase erosion, especially, I should preface this by saying winter is not going to get drier. Winter is likely to continue to get wetter. It's just we're going to get more rainfall instead of snowfall, which of course will increase erosion. At the same time, if we're warming temperatures in the winter, it means that we're not freezing soil as deeply or at all. So that of course increases soil erosion that way as well, runoff, and the potential for winter flooding. We've also seen these changes in swings from pluvial to drought, in some cases back to pluvial. Wet to dry to wet is something that has been explored. Now, as far as the impact of these short-term drought events and these swings on water supply, really not clear that there is any impact there, but agriculturally and ecologically, they do have some pretty significant impacts. So the causes of those are still not clear, but that is something that we're seeing as a possible long-term trend. So in summary, I've talked a little bit about this. I include my contact information here. I just say climate change overall, present, future, poses a significant issue for soil and water management in Illinois. Over the last 30 years, we've seen increased precipitation intensity. We've also seen something I didn't talk about with temperatures, increased evaporation driven by higher temperatures, but those have been offset by additional precipitation. What it does mean is when we do get dry months like we did in September last year in Southern Illinois, it means that when we increase temperatures, the enhanced evaporation can actually exacerbate those dry conditions. Overall, I say at the bottom, it's highly likely that as temperatures continue to increase across the state, precipitation will also increase, especially in the spring, where we've seen a lot of those flooding-related impacts. And that is likely to continue in worsening flood-related issues, soil erosion, nutrient runoff, and flash flooding across the state. So with that, I thank you again for Nancy and Lisa for letting me speak. And would you like me to turn it over to Sally at this point?
Yep, let's turn it over to Sally.
All right.
Sally, I think you're still muted. Oh, looks like I can unmute you.
Sorry about that. Can you see what?
No worries. We can see your screen.
Okay. So hello, everybody. Again, I'm, as Lisa introduced me, I'm Sally McConkey. I lead up a group at the Illinois State Water Survey called the Coordinated Hazard Assessment and Mapping Program. So the Water Survey is part of the Prairie Research Institute, which is part of the University of Illinois. And I'll show you a picture of our group. There are actually more of us now. There are about 25 of us. And we work, I guess the primary emphasis of our work is working with FEMA as a cooperating technical partner, which means that we get funding directly from FEMA. We work with the Illinois Department of Natural Resources, Office of Water Resources, who have regulatory authority, and FEMA in order to prioritize studies of flooding in Illinois and producing regulatory floodplain maps. But we produce a lot more than just floodplain maps. We produce a lot of other tools as well that are helpful in understanding your flood hazard. But today, I'm really going to be focusing on just knowing your community's flood hazards. And as Trent pointed out, I think we are going, we are definitely in a time period where our flooding is expected to increase. So it's really important to understand where it might flood in your community and then start planning some actions that you can take to try to mitigate the impacts of that flooding. So takeaways from my presentation, it's going to be kind of simple, sort of plain stuff. How to locate and understand where your community floodplain maps are. Understanding a little bit about the National Flood Insurance Program, and hopefully if your community is not already participating, that it will give you some reasons that you should be participating. How to find out if you are participating, just a quick look at where you can find that information, And then I'll wrap up with some other community actions to mitigate flooding impacts. So flooding in Illinois. You may not need a lot of motivation if you've been in one of those communities that Trent was pointing out that have experienced a lot of flooding or intense rainfalls. But just to kind of underscore that, Illinois has the largest inland system of rivers, lakes, and streams of any state in the nation. And what you're seeing on the right is a map of the streams that actually we have floodplains mapped for those streams. And they are part of the what I'll refer to as the FEMA affected floodplains, which means they've been adopted for regulatory purposes. So many of you, I don't have any idea of the age of the people that are listening to this, but I would imagine most of you, if you weren't there and witnessed it, you heard a lot about the Great Flood of 1993. And it's been 27 years since then, but every year our rivers flood, and many years that flooding has led to extensive damages. And year after year, the cost of those damages are accumulating. So I'm just going to show you just a few examples of more recent flooding. Just real quickly, kind of running through these here in 2007, we had flooding, particularly in northeastern Illinois. Picture shows Albany Park neighborhood in Chicago. And on the right, what you're seeing is a map showing all the counties in Illinois. And those counties that have the colors of red, yellow, orange are ones that had damages sufficient to qualify for a FEMA federal disaster declaration. So that's pretty extensive damages. There's a formula that's used to determine declarations, but it happens when the damages exceed the expected capacity of this county or the community, the county or the state to deal with it. And so you bring in the federal money. In 2008, we had a lot of flooding. I just pulled this up. They're being images, hope I'm giving proper credit. And again, the flooding of 2008 led to disaster declarations along our western side of the state, as well as in the Wabash area and northern Illinois. 2011 floods. These were caught a lot of attention because of the action by the USGS under the Corps of Engineers to blow. I'm pointing here to the Birds Point levee that was blown to kind of orient you. Here's the Mississippi River moving around, very meandering river coming down. At this point is where it joins the Ohio River, or the Ohio River joins it. Here's the city of Cairo right in between these two. And this Birds Point levee was the one, there were some dramatic videos about blowing that levee in order to activate this floodway to reduce the pressure on flooding in Cairo and other areas. Pretty dramatic. It led to a lot of counties declaring a disaster, but it wasn't just along, if you look at these counties here, it's not just along the river. Here's Cairo down here. But there was a lot of rain and a lot of flooding that happened in the interior of the state, I would say. And just look at 2019. Again, more flooding in 2019. We had disaster declarations along the western part of the state. So as you're watching this, maybe you've seen your county come up here as part of a disaster declaration. It's not just the big rivers that flood. We have a lot of flooding throughout the state. And in fact, every county in Illinois has had a disaster declaration that had something to do, that had flooding as some component of it. So as noted here in the slide, the yellow, it used to be that this depiction of the counties with disaster declarations actually had some different colors, but now every county has had this disaster declaration related to flooding. Flooding's contributed to 37 of our 52 federal disaster declarations since 1965. Every county has had a disaster declaration, and by far, that's our most common and most costly disaster in Illinois. So the takeaway here is flooding happens every year in Illinois, everywhere in Illinois. And my key message here is that we need to avoid or mitigate flood damages. Floods are going to happen, but flood disasters don't have to happen if we take actions. So the first action to do is understanding where it might flood in your community. And while some communities may have their own floodplain mapping, and certainly there's some criticism of the federal flood insurance rate maps being a little out of date, but they do provide the most extensive coverage. And we're working really hard to try to get them to have the most updated coverage of where you'll see flooding. So I'm going to do just a short little primer here on flood insurance rate maps. There are many versions and flavors of the way the floodplain mapping data, flood data is presented on maps. On the left-hand side is, you can see these, the old paper maps. We always say that with disgust, because they're very clumsy and hard to work with. And if you're dealing with the paper map, it means you probably have old data. We're working very hard to elevate that information to a digital platform so that most counties, most people in their communities will be seeing data that looks like what you see on the right, which is our digital data presentation. And I'm going to point out a couple of times in interpreting these maps, sometimes they can get pretty colorful with all the information that's presented. And I'm having trouble with my pointer. It keeps disappearing on me here, but hopefully you can see that I'm pointing to the cyan area. That is the special flood hazard area. That's the area that has a 1% chance of being inundated in any year, or AKA the 100-year flood. And there's my pointer coming again. This candy stripe area here is the floodway, and I'll talk a little bit more about that. But that's the area that needs to be maintained as open space or open area to manage our floods without increasing flood elevations. Okay, I'll get back to that, talk more about reading those maps, but I wanted to give you a little preview if you might be dealing with paper maps or dealing with or better yet, that you'll have digital data. Here's our coverage in the state, where the green indicates that you've got a digital firm. You'll be able to pull up digital data. We have a couple of red counties, Ford and Warren. Those are going to have digital effective data very soon. They're out as preliminary maps. I'll point out the peach colored counties are ones that studies are in progress and we're moving towards digital data. The counties that are white, we have not secured funding yet to go to a digital platform. So those are definitely dealing with the old paper maps, but we work with FEMA and OWR, working that hopefully we're hoping by 2025 that we'll have complete digital coverage in the state. But if you're in a county that's white or peach, you're going to be dealing with those paper maps. So how do you access floodplain maps? Up here you can see I've given you a website, but if you remember to Google FEMA, MSC, Map Service Center, something like that, you'll find this page. And here's where you can get effective maps, old maps, studies that have engineering data, letters of map change. That's when there are geographically small modifications to the map floodplain that are issued through a letter process. And also when you've got that digital data, you can download that digital database. So going here, you get to this point. So this is how you do it. You get to the Map Service Center, you're looking for a floodplain map. Let's kind of zoom in here. So looking for a floodplain map, you just enter an address. It is simple. You can put in your home address, you can put it in your county, you could put in your community, and I put in Champaign, Illinois. That's where I live, and press search right here, and this is what you get. Well, that looks a little confusing, but fear not. You can zoom and pan on these. I'll again point out, just as part of this understanding your maps, that cyan color when you've got digital data, that's your special flood hazard area. That candy stripe area is the floodway. There are different types of areas, but I'm not those are the two main things to understand. So once you get to that point, you can zoom and pan. I zoomed in pretty close to where I live. I don't live near a floodplain, thank goodness. So this isn't where I live, but it's pretty close to my neighborhood. And you can zoom in to any place. So this is a really great tool for people if in a community, if you want to direct your citizens to where they can find out about their flood hazard. They can go here and very easily put in their address. As a community administrator, you could put in, your town, but you can also get much larger data sets. So if you were a researcher or working on a watershed plan, you could access this information. There are different views that you can go to. I'm showing you here, the first one is a window that I was just showing you. It's a little bit more clumsy to navigate, but right from that website, you can go to the National Flood Hazard Layer Viewer. And here you can even print little maps if you want to, or you can go to other views, same information, still this National Flood Hazard Layer Viewer, play around, turn different things on and off. Over here on the right, I'm showing you a menu of different features you can look at, and you can also download the digital data. So this is how you can access data if you have digital flood insurance rate maps. So just a recap here, you can go to the National Flood Hazard Layer, and again, it's really easy. Just Google NFHL, FEMA, something like that, and you'll get there. You get an online interactive map. You can load it into Google Earth. You can also download the data for use in GIS software. So say if you're a community administrator, researcher, whatever, and you work with GIS, you can readily download these data sets so you can layer them with information that you have that's pertinent to your community. Okay, so what if you don't have any digital data? Well, going back, I didn't put a slide in here, but back when I put in Champaign, Illinois, if you had put in Washington County down here, this is what you would get from that FEMA MSC site. And you would see that you've got this kind of polka dot image, and there isn't any over here in the legend, no digital data available. But still, from the same site, you can get what paper maps are available. So going back to that service center here, I put in Washington County. I did search. I searched for, oh, sorry, I got a little ahead of myself, but I said search all available data. I got this for Washington County, unincorporated areas. If you have paper maps, unfortunately, the cities are on a separate set of maps from the counties. That's one of the big advantages of having digital data that you're just gonna have to struggle with if you have paper maps. If you go here and you want to see what the effective maps are and click on that, then you get this list. And from here, you can either download the maps or you can view them. So it's a little clunkier. You're not going to be able to pull that digital data into your GIS, but you can access it from this menu and this point. So I've used a lot of terms, and I realize that you're probably not going to be fluent in FEMA-EASE. So I wanted to offer this page and try to get you some understanding of what these various terms mean. But the National Flood Insurance maps that FEMA produces, and that's where we've got most of our coverage, they have what they call the base flood. There's my pointer again. So the base flood, that's the same as the area of the 1% annual chance flood, which we're trying to get away from this terminology, but people refer to as the 100-year flood. Base flood elevations, that's how high the water might get at a particular location. They're referred to as BFEs, and that's the 1% chance flood elevation. So that's the elevation of the flooding, how high that water is likely to get an average, or it has a 1% chance of occurring in any given year. When we do studies, some studies are approximate and they don't have those base flood elevations. You'll just see the extent of the floodplain map. Floodplain maps identify the base flood plain. So these are all the same, just different ways of kind of getting at the same thing. The base flood elevations. The base flood plain is this special flood hazard area. It's a land area that has a 1% chance of being inundated. And again, that older terminology, the 100-year floodplain. So those all mean the same thing. As far as floodplain management regulations, if you are in the Nfip, the National Flood Insurance Program, and you've adopted regulations, those regulations apply to areas in that base floodplain. And flood insurance is required for structures in the base floodplain whenever there's a federally backed loan. And that's called mandatory purchase. That applies whether or not the community's in the Nfip. That comes through the financial sector, and it applies to loans that would be like from Fannie Mae or Freddie Mac or veterans loans, so federally backed loans. So that's a lot. But the point being here, just, when I say the base flood elevations, that's the 1% annual chance flood. And that's that's the main focus of what's shown on the flood insurance rate maps. Okay, that was pretty boring. This isn't much better. But when you do download your maps, I'm assuming everybody laughed at my cute little joke there, but if you study the map legend, there are lots of there's been different formats used over time. If you've got that digital data, you'll see this on the left, digital from legend, again, that cyan area, we call it a special flood hazard area. That's the base floodplain. And you'll also see that candy striped area, which is important. These are the two most important ones that I'll talk about today. But you'll see the other colors here, other areas of flood hazard. These are the main focus though. If you are stuck looking at a paper firm, they will have different types of legends. But again, the shaded area called Zone A, the older ones will have them numbered A1, A2, A5, whatever. That's again, that special flood hazard area, the 1% chance flood event. So when you're working with your maps, just take a moment to look at that legend. I'm going to segue here for just a moment and I got these slides from Paul Osmond, who's the National Flood Insurance Program Coordinator in Illinois, and he teaches courses on what he calls Floodplain 101. And I borrowed these slides from him because he's a non-engineer and he tells me that engineers don't communicate well, which I believe that. So I'll try to use his slides and give you a different view on flooding. So understanding the floodplain, we have, down here, just, normal stream flow. About every other year, stream will get out of its banks. So you'll see that just about every other year, you'll see the get out of its banks and flow into perhaps this area. The base flood, 100-year flood, is really a pretty extreme event. You see it goes well out of this lower floodplain up into here. And over here, illustrated on the left, is a house that is elevated above this 100-year or 1% annual chance flood elevation. High and dry, they're doing just fine. They should be able to weather this event, climate change notwithstanding. But let's talk about the floodway. The floodway, a regulatory floodway, is that part of a river and water course, so part of the floodplain, that has to be left in open space so that we can move that water downstream without increasing water surface elevations on our neighbors. In Illinois, that standard for not increasing water surface elevations is 1/10 of a foot. So what happens if you obstruct the floodway? This is why we have floodway regulations. And I'll say that whether or not a community is in the Nfip, the state regulations apply. But over here, if you put this fill in here, okay, and you build this building, now when that 100-year event or 1% annual chance event happens, the water's got to go somewhere. And what happens is that it goes over and floods your neighbor who previously was in good shape and floods your building. So we have these regulations in place in order to not create hazard or not increase risk for others because of our actions. So, okay, why should your community participate in the National Flood Insurance Program? And many of you may not be in a position to actually advocate for this, but I will at least explain what it is very briefly. And I would encourage you, if you are a local administrator, to make sure that your community is in the National Flood Insurance Program. I won't belabor this, but it is a voluntary program. Communities can opt in or opt out. If they do agree to participate, then they adopt these floodplain maps I've been talking about, and they do adopt ordinances which would keep people from increasing your flood risk. It's good management of your floodplains. In return for this, flood insurance is available along with disaster assistance, grants, and loans. Now you have to, it's done by, they call them communities, but a county, unincorporated areas is considered a community. A city or a town that's incorporated, each joins individually. So 89 of our 102 counties are in the program and 801 communities. So the NFIP, just kind of wrapping this up, the goal is to reduce flood losses, and you do it through 3 ways. You do floodplain mapping, which is what my group does. We try to show you where that flood hazard is. You adopt ordinances so that you do good floodplain management so you don't put more stuff in the floodplain. And for people that already have structures that are in the floodplain, that's, you know, they maybe have been there long before the maps were created, you buy flood insurance, and that's a way to mitigate your losses. To find out if your community is in the NFIP, it's very easy. Again, you can do a Google search, but FEMA has a community status book. It's really a pretty plain PDF that you can pull up. And if you might have to poke around it, you might want to get to this link to make sure you get to the Illinois PDF. So it has this list for Illinois. It'll name all the communities, what county they're in, their current effective map date, and just information that says that you are participating or your community's participating. We also have a naughty list. And here at the bottom of that PDF is communities not in the National Flood Insurance Program. And again, you can look up, you can see when your maps were issued. So those were, actually this one was issued in 2010, but they didn't adopt the maps, and they've never participated in this program. So calling them out here. So joining the NFIP, there are brochures. A great place to start is with this one, joining the NFIP. I Googled this and got to this library asset, which had several different things. This was the recommended read first. You contact Paul Osman, who I mentioned earlier, our NFIP coordinator. There's also a new manual out that's produced by our National Association of Floodplain Managers. You can read this guide, and it's understanding how to manage your flood risk if you're an elected official. And kind of wrapping up, I'm going to go through some other measures that a community can take to reduce the impact of flooding. There's programs such as the Community Rating System, that's called CRS, and basically a community that has a lot of floodplains policies can take advantage of this, and by doing certain activities, they can reduce the premium cost. They can go into hazard mitigation planning, and I see I'm running low on time. I apologize. So I'll get through these. We have hazard mitigation planning. Should be sure that your community is participating. You can make sure that you can get training for your floodplain manager to make sure that they are fully trained and a certified floodplain manager. And see if your community can adopt a floodplain model ordinance. If you don't have one, there's a model ordinance, a stormwater ordinance, a stormwater ordinance, and there's a model ordinance been published by DNR. You can join our state chapter for floodplain managers. And so again, I hope that this has been valuable information for you. You can locate your maps, figure out if you're in the if your community's in the NFIP, determine if your community participates in that National Flood Insurance Program and advocate for it. And if you're in a position to really promote other community activities to mitigate flooding impacts. Okay, I am done. And I guess that Nancy's going to take over, or Lisa?
Yep, that's Lisa. I will take over. Let's take just a couple minutes for a couple questions that came through, and then we'll sign off. The one thing that got repeated is, how do we get access to the Bulletin 70 and Bulletin 75?
Okay, I can take that one. Bulletin 70 has been around for a really long time, and that can be, I can send out a link to it, but it can be, if you Googled it, you would probably come to the University of Illinois State Water Survey, and you could download a PDF of that bulletin. The Bulletin 75 isn't quite, I think it's going to be published in a couple of weeks, but there are 2 precursor contract reports that can be accessed again. If someone could contact me offline, I can give them my email, and I can send you some links where you could find those.
That sounds great. And we can also, maybe I'll send you a note, and we can include those in the notes in the follow-up that we send to all the participants, if that works.
Perfect.
All right. Another question we had for Trent. Trent, you made a comment that global warming and climate change are not synonymous, and one of our listeners asked, what do you mean by that?
Yeah. So responding to Nicole, yeah. So it is a common misconception that they're used synonymously a lot, especially in the media. So global warming just describes the increase in global average temperatures. That's linked directly to changes in greenhouse gases. But when we talk about impacts related to precipitation, that's a change in our climate, and it's caused by global warming, but it's not the same thing. So I like to shift people's focus to say, we can focus on global warming. Global warming is pretty well known. We can measure it pretty easily. What we really need to get down to talking about is climate change, which is caused by global warming, but is much more difficult to measure. So although they're used synonymously, global warming and climate change are two different things, and global warming actually causes climate change. Does that help?
That helps. Thanks so much. One final question for you, Sally. You pulled up that map where you showed the communities that had digital maps and those in, I think, peach and yellow that didn't have them yet. Do you have dates on those peach-colored areas, or is there any estimate for when that'll be completed?
I would say that each one of them will have a different date. They're in different points in the project going forward. And people could contact me and I could give you some proposed, some projected dates. They're not really published anywhere because they are a work in progress. I would say anywhere from within a year to 3 years.
Perfect. All right. Well, thank you so much. Let me get to my ending comments here. So we've taken our questions. Nancy will put up a poll here in a minute. So if you'll give us just some quick feedback, we'd sure appreciate that. And we thank you for participating today. And please feel free to join us on April 9th. We're going to have kind of a corollary to this presentation where we're going to talk about insect-borne diseases, particularly mosquito and tick diseases that tend to crop up in the spring, particularly with more rain. So that's April 9th at noon, and we hope you'll join us for that. And with that, thank you so much, and we'll talk soon.
Thanks, Nancy and Lisa.
Thank you.